My name is Rustam. I want to talk today to you about data pipelines, and that's kind of something that is might be a bit confusing, and well, you might think, well, I mean, data pipelines, how fun can that be, right? Well, actually it can, I think. I'll try to convince you. I mean, if you're not convinced, let's talk outside afterwards, but I'll try. I'll do my best. So, before we get started, I kind of try to show you this kind of as the end product. You show it first, and then you go back and you explain things. So this thing, right? So then you can actually ask if that works. That's always fun, because that's the kind of the live demo thing that if you did not offer, sacrifice enough code and stuff to demo gods, it might fail, but we'll see. So, hey Google, what's the bike availability at the stop next to my house?
There are 5 bikes available at the moment. Based on historical data, the availability for this station will be decreasing for the next hour. I would suggest getting your bike within next 10 minutes.
Ha! It worked. So that's the point, right? So then you get this bicycle thing going, and that's what I'll be using as an example for data pipelines. And the reason I had to do that, it was just it was simple. I wanted to learn about Apache Beam, which is the thing that I'll be talking about. And then I was looking for examples, and I couldn't really find proper good examples for that. So I realized one thing. So if we go back a little bit, kind of back in time, so there is this thing in Oslo. So this is Oslo on your right. And this is San Francisco on your left, and this is Madrid. So it's kind of the same thing, right? You see those bicycles there, and you can hire them, or you can borrow them for a short period of time, and then you put them back into these locks. You pay for like monthly or yearly fee, and it's very, very cheap. But the point is, most of the time they're kind of being sold to us. This is actual. I asked them to borrow the marketing pictures from the city bike people. So they gave me this, and this is how they kind of selling it to you, like summer green, and it's like it's fantastic, it's amazing. There are bicycles, and you're just biking it, you're enjoying everything. This is how summers in Oslo look most of the time, whenever they don't look like this. But well, I mean, that's not summer. So back to summer. This is another kind of, this is marketing pictures from Oslo City Bike, which is really cool. And then you have this one. So if you understand Danish, you'll probably understand what it says in Norwegian. It says spring, tra-la-la, spring. So they're kind of advertising, well, spring is here and bicycles are there and everything is right, is perfect. And well, the thing is that in most of the cases when you get to, you buy the membership, you get this card and you get everything, and then you actually want to bike. The locks look a little bit different. They will either be totally empty and there will be no bikes there, or they will be totally full. Whenever you actually find a bike, you borrow it, you bike to where you're supposed to go, and then you try to, because you have to lock it in. If you don't lock it in, then they will give you fines and stuff and things like that. And then you're coming there and everything is full. So you're like, shoot. Then you have to spend another half an hour or something looking for a place where to park those. So then you get a little bit sad. And then you were like, okay, fine, I can do IT, I can do code. Everybody stand back, I'll fix that. So you start making the plans, and then you kind of start with this. The kind of, I try to illustrate the train of thought right here. So you start with like, okay, well, there are no bikes. Well, that sucks. Okay, fine. What can we do about that? Well, I mean, where can I find another bicycle? Where can I find one? Well, I don't really know. That's how it is, right? Can I use an app? Well, no, because the thing is that the app will give you the kind of right now situation in the app and say, well, at that stop there are 2 bicycles available, and you know that it will take you 5 minutes to get from your door to that stop, and by the time you get there, there will be no bikes, because for reasons, right? Then you're thinking, okay, fine, can I use a public API? Because these guys actually I don't know how it is in other places. I don't know how it is in Copenhagen here. But in Oslo, they actually offer a public API for that. So it's open data set. I was like, OK, cool. Maybe I can use public API. That's fine. And then the thing is with that public API is that it does not offer you any kind of historical data. So it doesn't give you any kind of idea how it used to be. It's just right now, right there. And then, well, you kind of want to collect that historical data because you can do stuff with it. So yeah, well, fine, cool. I can collect that. And then you can do, OK, how do you store that all? I mean, I can put it in files, but it won't give me much. I need to put it in some kind of database, data warehouse, whatever. Cool. And then the next question would be like, how do I actually do that? Do I go like full enterprise as an enterprise developer? I mean, I'm working with enterprise stuff every day, and you're like, yeah, I'm going to spend like 300 million whatever dollars, whatever, on software and build that thing at home, and then I will have my bicycle there whenever I want it. But yeah, no, it doesn't really work. But then you can actually, then you realize, well, there is something that is portable, it's open source, it's free to use, and so on, so on, so on. And then you get a bit happy, and then you have this, the last step is like, well, profit, right? You usually have 1, 2, 3, step 1, step 2, and then profit. I had like 9, but still, you get to profit. So, a few words about me. Kevin introduced me already. My name is Rustam. I'm I'm organizing GDG Cloud meetup, a very similar thing like this one in Oslo. I also work for a consultancy company called Computas in Norway, and then, well, we have a small office here as well. I have been quite heavily involved for the last quite a few years, actually, since, 13, 14, something like that. I was quite heavily involved in the Norwegian Java user group. I was leading it for 2 years. And then when I was done with that, we have to, like, after 2 years, you have to pass it on to someone else. So I did that. And after 2 years, they asked me to take over this conference called Java Zone, which is a, community-driven, non-profit conference for 3,000 people in Oslo. It's been there for 17, 18 years now. I think it's our 18th anniversary this year. You might have seen the fake movie trailers we've been making throughout the years with all the making fun of Java people and .NET people sometimes. Anyway. And a few years back, I got also an honor to be a part of this Java Champions community. That's where it's very few people. I think it's a few hundred people in the whole world that gets this title, and then it's really, really cool. So it's something similar to, I guess, GDEs or MVPs in like Microsoft or Google world. Anyway, so that's me. Back to our problem. So when you do this kind of solution, you end up with some kind of architecture stuff. Because, well, I mean, I work with code and everything, so I kind of end up with drawing the architecture. And then you do write something like this, right? You would have some kind of thing doing a cron job. So technically, it could be just a cron tab job that will run every so many minutes, and it will dump the contents of those APIs. I'll show you those APIs in a second. So it will dump the contents of the APIs into some kind of file system, right? So you store them here. Then you process it with something, so like something like Apache Spark or anything else that will be able to process it. You'll dump it into some kind of data warehouse, and you'll show it with graphs and stuff for the end user. Or you can do some other stuff on top of it, like building this assistant thing that I showed you earlier, or things like that, right? And then you have the streaming version of that would be a little bit different, where you have, instead of batch files and kind of batch things, you will have a constant stream of data, but then you will do the same thing. You'll put it into some kind of a queue, RabbitMQ, whatever, any kind of queue system. You'll process it with a proper thing like Apache Storm or anything similar that can do streams. And then you'll show it on some kind of dashboard. So you end up with like 2 different pipelines depending on what your input is. And that's cool. That's totally cool. I mean, that's how it almost started. I had a Raspberry Pi on my table for like almost half a year in the first half a year of this project running, and it did this part. Because I could do the cron job, and I could store it in a file, but then I couldn't do that much about it really, and it was just storing lots and lots of files. Then Raspberry crashed. I think I lost most of the data, but well, you know, it's a local stuff. And then, well, then you kind of upgrade to another machine, and at some point your house starts looking like this, which is a bit kind of sad. I mean, it's totally cool. It's really nice in the winters because you don't have to pay for the heating, but it's not very popular for some very, very, very odd reason. It's not very popular with the rest of the family kind of thing. I don't know why. I don't really understand. I mean, so look at this. But okay, and then you get a bit sad again. So the puppy will be kind of showing up from time to time. And well, you get sad and it's like, oh, you know, I can't run this thing locally and everything. And it takes quite a lot of piping, and you kind of write your own Python code or Java code, whatever, that will split the files and do all these things, and things change and things break, and well, you know, sad puppy. And then you find out that there is something that can do quite a lot of fun things for you. So you find out this Apache Beam thing that lets you to create one model for parsing your pipelines and ingesting your data. It can do both batch and streaming. You don't really have to change much. It offers you two kinds of API. So it has a Java API that historically has been kind of the most complete one. It's been quite feature heavy and so on and so on. That's kind of the thing. And then you have a Python API that is kind of up and coming. So it's a little bit below on the behind on the features and stuff, but it still works. And then it has a bunch of connectors, so you can read and write to a bunch of different things. So this thing on the side is just an example. There are more things you can do. But the cool thing is that the most important thing is that you can actually do it as a local run. So the first picture there on top, you can run it on your machine, or you can switch to run it on the cloud by just one click off. You don't really have to change any code. You just do a tiny little bit of configuration differently. I'll show you that in a second as well. And then you end up, if you go back to this architecture thing, so we had this, right? So we had a batch processing, and we had a streaming processing. With Apache Beam, you can do it, you simplify that. So you can actually do both batch and streaming. You put it all into a Apache Beam pipeline. It will kind of do its stuff, and it will put it into some kind of database, and it will preview it. You will be able to preview it in one way or another. So if we translate that from kind of generic stuff to the cloud stuff, it would be something like this, right? You have a cloud function doing the dumps from the API, because API just gives me right now picture, so there is no historical data. I have to do it myself, so I do that. I store it in a bucket of some kind, and then if I have processing, I will have some kind of queue, some kind of publisher-subscriber kind of thing, and I'll process it in no matter what, the way it comes in and stuff, and I'll put it in some kind of warehouse. So in this case, it's a BigQuery, and I'll show it with something. So in this case, again, it's data lab, or you can do anything. You can do like a web page or just a table for those of you that way inclined. And it also could have been any other cloud, really, because you have cloud functions you have in anywhere, and buckets you have anywhere, and you can do, and you publisher subscriber kind of thing you have everywhere. So you can do it on anything. I'll be using Google examples. That's because that's the cloud I've been working most of the time with. But feel free to ask about the other stuff as well. So pipelines. What is a pipeline? A pipeline is a simple thing. It's like you put something in, it goes into different pipes and mixes and turns around and something, and there is something else coming at the end. So for those of you that like remember this old meat mincing machine? that you used to turn around, like back, I remember I was a kid, we had this, it was really fun. But then you put a piece of meat or whatever, for if you're not meat person, if you're a vegetarian, put I don't know, potato in there. But the point is, you put something, it kind of turns and does stuff, and there is something in totally different way rearranged comes out at the other end. So this is what a pipeline is. If you're going to go to a more kind of formal definition, it is a acyclic ordered graph where you can do things and magic happens. That's a very formal definition of that. So you put something on top, you get something on the outside, on the other end. And it's acyclic, so there are no cycles. You can't just go in a circle because then your potato will never come out at the other end. And kind of boring, you're just turning around, nothing happens. So if we go to a simple pipeline, so that's a simple pipeline. It's kind of easy. You put thing on top, and it's most of the time it will come out at somewhere. I hope not there, but well, anyway. I don't know, it's not really clear in the picture where it ends. But don't think about that. Okay, so back to data. So you have two APIs, right? You have the Oslo City Bike thing. It offers you two different endpoints. It has one of them is information about metadata about station, information about station. That's the one you see here on the right. So it has an ID and it has a title. It tells you where it is. It tells you how many locks it has. It has like some geographical coordinates and stuff like that. So all kind of information. And that's one big list of IDs and stations. So you get all of them at once. It's all or nothing kind of API. And then you have on the other side, you have all or nothing API of the availability right now. So that one has an ID. It has how many bikes are available at that stop, how many locks there in total. And then you can do fun stuff, actually. You can, and well, it provides you some information, right? But it doesn't tell you where that station is. So you have to merge those two data sets together at some point. This is not going to be a simple pipeline. We'll do that later. But simple pipeline is just to ingest one of them and try to get something back. Because, as you might have noticed on the left side there is no timestamp. And the reason why it's not timestamped, because it's a very long list. And at the bottom of that list, there is one variable called updated at, and it will have a timestamp. So if you're going to put that thing into some kind of warehouse, you already have to, you have to flatten that thing so you don't do like a nested availability bikes and locks. You want to kind of flatten that. You will just have ID, locks, and everything. And the other thing, you would also want to put a date next to each row. You don't want it to have like a bulks of that. And then the other thing you can do is also quite a fun thing, because I think I did not mention before is that those bicycles, they're kind of sometimes a bit tricky, because you actually see that there are two bicycles at the locks, and you're like, yay, finally, I can actually get something for what I'm paying for. And then you come there, and those bicycles are locked because somebody reported them broken. So then there is no bicycle. So what you can actually do, you can actually take number of locks there. So it says 30. And then you can actually deduct the number of broken bicycles at that stop at that moment by putting those two together. So 4 and 24, that would be 28. And let's say that's the same station here that says number of locks is 30. So then I know that there will be 3 broken bikes there at that point, because it shows me available locks and available bicycles. And well, those bicycles that are not available, there is something wrong with that thing. And so by combining this data, it gives me quite a lot of things, but it's not that easy to do that. I mean, go parse that with something and make it not break all the time. So the pipeline, the simplest pipeline, that would be like this, right? You have an ID, you have number of bicycles, number of locks available. Overflow capacity doesn't really matter. Don't really think about that. But it's basically that they don't, whenever they drive the bicycles with the car and refill the stations, but when they refill them, they just leave a few locks open. So whenever you come with the bicycle, you have somewhere to park. So this is the overflow capacity thing. And then you have a timestamp, right? So how does this look in code? How many of you have worked with Java? Okay, well, about half. Good. Because all the examples will be in Java, but it's so much, it's quite easy to transfer it to any other, to Python. Well, the other API is in Python, so it's pretty easy to do that. So don't worry about that. So the weird and kind of confusing thing with Apache Beam was that you kind of have to twist your brain to understand functional programming, and you have to do it also. You have to also understand that your code will be run in parallel on many, many machines at the same time, so you cannot do things that wait for each other and stuff like that. So you have to kind of keep all those things in mind. And one of the first things that kind of forces you to that is this concept of pardoes. Well, pardo, that stands for, surprise, surprise, parallel do, that lets you parallelize things. Captain Obvious. That's my second name. So you do have a pardoes, for example, like reading files and reading contents and creating objects of that. That's a perfect thing to parallelize because they don't depend on each other. You can do it on 1 million machines at the same time, and nobody cares because, well, you read that and you convert that, and it's perfect. So you define things as pardoes, and the code would be looking like something like this, where you have an object, you have a pardo here, and then you define a class that will do, in this case, for example, conversion from JSON, like string of a JSON string, to a Java object. So I wrote that class. I'll show you that in a bit. And well, this is something that can be parallelized. So perfect. Okay, then I'll do it as a pardo. So this is the kind of the simplest part of the simple pipeline. So this is one of the things I do. And within that class, I will also do a bit of like putting data, the timestamps into the same row, rearranging things in a row, and stuff like that, right? So say you write that simple pipeline with pardoes and everything, then you want to run it. The way you run it is like this. You run it with Maven. With Python, it will be a little bit different. But the point is that it has a few options. So you have one of the options is like direct runner. Then you define your main class, where well, the main method is, which has to be run. And then you do a few other parameters like input, where the folder where the input data is and the folder where you write the outputs. Fair enough, right? So you run that, it works on your local machine, but the thing is that your code is there and you don't really have to do anything to make it run on the cloud. So only thing you have to do is to add a few parameters. So I'll switch. And then I will jump a little bit back and forth so you can actually see that there is lots of things. Oh, that's the wrong button. A few things that change, but in general, it's almost the same, right? You have direct runner, the first parameter there. The second one is Dataflow runner. So you switch to Dataflow, which is the managed version of Apache Beam on Google Cloud. You still have the main method. You still have the kind of arguments. Then you have to specify a little bit more Google Cloud specific parameters, like your name of your project, and well, the Google storage link to where your files are, and so on, so on, so on, right? But in general, it's almost the same. The thing that's important to remember, and that was kind of, I learned it a bit hard way, is that you need to have specify if you're going to dump the data to a BigQuery, make sure that you have the same region for BigQuery and the processing. Otherwise, you get really, really weird error messages, and it's a bit frustrating. But, well, you know, you've been warned. So, simple pipeline. this is what it looks like, right? I showed you a tiny little bit of code earlier, and that's the one that does the read lines. That's the kind of the first thing that I showed you. And okay, we have it there. Okay, it's back. Cool. It's the demo gods. It worked. The demo worked earlier, so now I'm kind of there trying to. I guess I'll need to sacrifice some kind of Java file or something for that. But okay, so you have something that does some kind of wrangling with the data, and then it maps some elements and does some stuff. It dumps it to BigQuery, and it's done. The cool thing is that whenever you run it on the cloud, it will generate you this kind of pipeline and visualization of that thing for you, just automatically. But if you do it locally, you won't get any of this. So you're kind of operating in a bit blindfolded, but man. And then you can see that I did read quite a bit of files. So this is quite an old pipeline. This was my first pipeline. I did it in September 2018. Well, one of the first ones anyway. And it took me around 20 minutes to process. I think it was like 4 or 5 months worth of data. So I think I started dumping all over again after my Raspberry crashed and stuff. So I started all over again in June or July or something. And that was September. So, well, that period of time. So it took me 20 minutes. It took me 17 machines to process that and dump it to BigQuery. And, well, it worked. And then this is how it looked inside BigQuery. I mean, you can see it's not much data. You cannot really call it big data or any kind of, well, it's data. Let's just call it data. It's 40 megs, 36 megs of data. But it's still kind of respectable number of rows. It's still 1.1 million rows in that thing. And it took me 20 minutes-ish to go through all that. Then I got brave and crazy. And then I decided, well, I mean, now we can do stuff, well, now we can actually merge things. Because I have my simple pipeline, now I want to start with 2 pipelines, I want to join them together in the middle, and then I want to dump. So I want to have all the data available in one big table. And it worked. It also worked. This been run May 16, so a month ago-ish. It's been run on all data for 2018. I did not use 2019 data, and I'll explain you why. It's a tiny little rant coming in a bit about API design and things like that. But, well, 2018 data, a few more months, so 3-4 more months worth of data. 2 pipelines, processing, doing a merge at, like, you process it, and then you do join by key at well, in the beginning, where they merge. And all that fun process took me pretty much, well, it's actually 16 minutes. It's less than the previous one. But the reason for that is that it always takes a little bit of time to kind of warm up and to create all the machines. But here it was, well, it was many more machines. And it was also, well, a few minutes shorter period of time. But then I had 16 machines or 17 machines on the previous one. This one had 25 or 21 actually. And then it also, you can see that it goes like gradually up, because it's like, okay, how much work do I have still left? Oh, I have still quite a bit, so I'll up it a bit. And then say, how much work do I still left? Oh, and then it goes up, 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 up. And then at some point it will be kind of, you will see that it's done, so you will kill all the machines there at the end. The other cool thing is that is a bit hard to see. I don't know if you can zoom in. No, I can't, because click works like something else. Okay. So here it says 3.1 virtual CPU hours, and that's actually a pretty cool measure thing, because it says. What it means is that if I would run it on one virtual CPU, it will take me 3.1 hours to process the whole thing. And that's what I'm paying for. In my case, I had 21 machines, so it took me just 16 minutes. Well, of course, you lose a bit by like startup time on the machines and everything, so it's not exactly 3 hours divided by 21, but well, still, it goes much faster, and you're still paying for, well, that hour, one CPU hour kind of thing. And the rule of thumb that we kind of realized that it was around 1 krona per 1 hour. So the whole mind-boggling number of 3 kronas was spent to process all that data. And that was quite a bit more data. It's 10 times more data, so it's like 360 megabytes of data. And it generated me 4.5 million rows inside BigQuery. And it just magically worked. It worked locally on my machine when I was testing it, and I just switched a few parameters, and then it just worked on the cloud. It's really, really cool. And then you get like, well, not the sad puppy, but you get the amazed monkey. I mean, it's always fun to have animals in your presentation, right? So, amazed monkey. And then you're actually like, wow, this is too good to be true. This was kind of my feeling first time it just worked. And I was like, whew. The other thing is that you can also change your pipeline. So now I have this pipeline of where I read files, I do some magic, and I'll dump it to a database or to another files or anything. But then a colleague of mine, he was a big fan of ArangoDB, which is like open source database that does lots of fun stuff. He was like, "Oh, can I have a bit of your pipeline? Can you just pipe some stuff to me as well?" And I was like, "Yeah, sure." And then I did that, and then he created this kind of map thing right out of the box, just because he had data in the database, and just you click, and it will kind of use the OpenStreetMap, and it will use Leaflet and generate map for you, and you can even do like queries and stuff, which is really cool. So the point is, it doesn't really matter what you're using. The point is that you can actually change your pipeline, and you can do dump things to different endpoints as well. The only thing that you have to make sure that you actually split your pipeline whenever you do that. You cannot just do the same object into that. You have to do some splitting and stuff. But, okay. So, the big picture, this is what we had, right? And it's quite amazing, right? But for now, we have actually implemented just that part. We don't have the streaming part. So I want to spend a few words to explain you a little bit about streaming and why it might be a little bit confusing. So this is the batch things, right? So we have days here, but in our case, it's hours or whatever. And by the way, I forgot to mention, it's 4 times an hour I'm doing that. So I'm dumping data 4 times an hour, so every 15 minutes. So this is how it looks for me now, right? But if we go to streaming, that will be like this. Oh, amazing presentation, animation stuff. But I mean, it's cool. But then the thing is that you have problems there. So you will have the data coming in with a known delays. You don't know when the data will be, like potentially, right? You might have like 8 o'clock data coming in there. You might have 8 o'clock data coming there, so a bit late. But then you might also have 8 o'clock data coming very late, which it's a bit confusing. And then you have to kind of try to do some stuff with it. And Apache Beam also lets you do that. So the pipeline will kind of help you with these things. And you can do things like, you can do like simple transformation. So you just pick something, you convert it to something else. You do something, you convert to something else. You can do aggregation, so you count number of things, right? And then you can do like composite things. So this is kind of what I'm doing. I'm kind of picking a little bit from there, picking a little bit from there, changing it a little bit, putting it together, splitting it, and doing things like that. So then you have to group it somehow. So one of the ways of grouping, that would be windowing. So you have a window of time, and then you kind of move it through your data and just see what's inside that frame. And then you can do also, whenever you do that, then you can do like put things in the buckets, right? So you can actually say, well, here's my old 8 o'clock data, here's my old 11 o'clock data, and so on, so on, so on, and then you kind of sort them there. You can also do things based on sessions. So for example, I don't know, email clients or games or whatever will be more interested in what happened within one session instead of when in time did that happen, and things like that, right? But to do all that, you can actually do, Apache Beam lets you do that in a very nice way. So you can actually do windowing with just tiny little bit of code. So you have your pipeline, which is called events in this case, and you do .apply, and then you do, well, I want to have a standard 5-minute window, and I want to move that window by 1 minute. So to do that, this is the code. That's it. Yeah. 5 minutes every 1 minute. So you just move it like this. And it will just give you that data. And then you can process it in exactly the same way as you were doing with batches, which is really nice. Then you have this thing, which is super cool, super amazing, but I did not get it working on the last version of Apache Beam. So you kind of pretend you kind of haven't seen that, because there is something wrong there. But it's like the whole idea is amazing, because you can do SQL queries, or you could at least. I'm not sure. This is the only slide I'm not really sure about, because it used to be working, now it's not. But the new versions keep on coming, so it might come back at some point. But the cool thing is that you can do select from where on the data that's not in a relational database. It's still in your memory, but you can do that. And you can do merges and stuff. And it's kind of, well, it's kind of worthy of Amazed Monkey, I guess. Yeah, so now we've had batches, we've had streaming. We put it all into the Apache Beam job, or Cloud Dataflow if you're running on the cloud, or any other cloud, anywhere. And, well, you store it, you show it. Then the cool thing is that you can also use all the other kind of connectors and endpoints. So you can do Kafka, that's the black circle thingies over there. Then you have Hadoop, you have S3 buckets. You can do, well, basically the point is, this is just an example. You can both read and write to very many different things. It could be databases, it could be Hadoop file systems and stuff like that. What I've been using mostly is to read or write to a file, or read or write to the cloud, to like a BigQuery or Google Storage, mostly, for this case anyway. And, well, you know, one ring to rule them and bind them and so on, right? So Apache Beam kind of puts it all together. And the code I'll be showing you in a second is there. So I'll probably tweet a link about that in a second, well, after the talk, anyway. But so take a picture of that, or follow me on Twitter, which I'll show you on the next slide where to find me, and then I'll show you some code, I guess. Who wants to see some code? Yeah, okay. Well, majority. So sorry for those of you who did not raise your hands. You'll have to live with it, I guess. That's the democracy. That's how it works. So I'll mirror this displays so you can actually see what's happening. I'll go into presentation mode, so you can actually see what's happening. So a little bit bigger fonts. Okay. So this is the code. This is the whole project. And for the sake of kind of simplicity, and so it's easy to go through and explain and show things, I decided to put it all into one file. In most of the cases, like, you probably would split it and do it a bit more kind of tidy. And I even put some disclaimers somewhere here and there saying that this is just for demos. Don't do that in your production code kind of things. But, well, okay. Well, let's start from the beginning. And the beginning is always at the end, right? That totally makes sense. But then you have the main method here. That is super tiny, and it has very little, I mean, there is very little happening. So you create a options object that I will show you in a second. And then you put that options object into a processing method. And that's it. If you go to the options method, this is a pretty cool thing. I mean, if you've done like lots of enterprise Java and things like that, this is not very surprising for you, but it's still quite amazing because you can declare like setters and getters for things, but then you also can like do at description and at default string. So you can actually do lots of you can define lots of options that will have default values, so you don't have to specify them every time. So here I was playing with a little bit of different things, so I actually created several default strings that I was commenting in and out, depending on what I'm running. So if I'm running locally, that would be like something like this, or something like that's active there. And if I would do it on Google Storage, it would be something like this. So if I just uncomment that so you can see the colors and stuff, it will be like this, right? So the difference is, well, the path, right? So you use the GS for Google Storage. And it has a bunch of parameters. And you can do things, for example, where is the database file thingy? Yeah, there it is. So here, for example, this is one that decides what's my standard output would be without me specifying that. So the standard, the default value is files, and if I specify it, I can actually say, well, I want to do it and dump it to BigQuery. So whenever that is done, we go to actually the beginning, and this is the, okay, let's search for Pardue. This is not, no, this, I don't want to show you this. I want to show you this. So I have two other classes that do the kind of parsing of, that's the one, that's the code I show you on the slides, right? So it does the Pardue, it parses it from a JSON file, and I have two endpoints, so I have kind of two classes doing that. So one is doing the availability data, how many bikes are available. The other one is doing the metadata about the station. And within that, you will have a class like this. Again, something that probably you wouldn't do like that in Java. This is a bit more of a Python way of doing that, where I kind of serialize JSON objects into hash maps. In Java, you'll probably create a class and stuff like that. But here, I just, to simplify things and so I don't have to create 1,500 million files or classes, I just decided to do it with hash maps. And then I just kind of create a hash map, and I put them together, and I return it as an output, as a key value store kind of thing. And if things fail, well, you just log it. So very simple. You probably might want to do something more whenever you go to production. The other thing is, so now we read the file here, we parsed it, we kind of created a bunch of objects of two kinds. Now we have to do some. This is the method that we were calling from the main method, right? Process Oslo City Bike data. And here I create two pipelines. So one of them is doing the station metadata, the one that we saw right now, right? The class that kind of calls again this dump JSON to hash map thing. And then I have another collection that is doing the same thing with availability. Then you have to do some tagging magic. You'll need that magic. You won't need that for a simple pipeline, but you'll need that magic for whenever you have to join things. Because what I'm returning back is key value object, like key value, this KV object that you've been, like here, for example, that you can see. And I decide myself what's inside that key value object, but it has to be a key value object, because then I can create a P collection, and everything is a P collection is in well, most of the things anyway, in Apache Beam. And then you do joint collection don't apply, and then you create another Pardue, another parallelizable kind of method that is able to pick those two pipelines up here, look at the tags, the way the data is tagged, and try to merge it and generate another key value object back, return an all key value object back. And I'm doing a bit kind of ugly things here just for the kind of demo purposes. So I actually felt obliged to write this. So okay-ish for a demo, not okay for production code, because it ends up in GitHub. And things into right places inside that hash map. Again, normally you would create an object and you use setters and getters to put it into that object instead, right? One last thing, I guess, is to show you, yeah, and here you can actually see that I commented out quite a lot of things, but this is actually working examples. So if you want to just run availability pipeline, you can use the first example, and it shows you an example of what it will return. If I would just want to do only station metadata, it will be like this. But then you can do also the final result collection when it joins everything. One cool thing is that it will write, use the text IO write, and then you can define here where do I want to output things. But you can also decide whether it should be stored in BigQuery or files. So I say here, I say like, well, if I want to, the format will be BigQuery, it has to be done by this. And if the format will be files, it will be done this way. So all these examples, they will dump things to file. I did not create a simple separate example for BigQuery for all those kind of things because it will make code ugly. It's not really the point. The point is to run it and see what you get, so you get the idea. It's much easier to look into the file. But, well, feel free. You can do the same thing for BigQuery. But BigQuery is a bit different animal because with this, you will actually have to define a schema. You have to tell how things will look like, and you have to define two things. You have to define how your schema, like database table, will look like, and then you also have to define how the heck Apache Beam will be able to convert the weird data structure that you created in your pipeline, how to map it to a row in that table. So you have to do two things. So this is where all the magic happens, and this is where I define things, which is quite interesting thing because, so this is the table schema. So this is how I define the schema, and this is the things you can actually see here. So you can actually do, you define a name for it, you decide what kind of data type it will be, so integer, boolean, float, whatever, timestamp. And then you can also set mode to things. So whenever you say not null, so you just say .set mode required. Default is not required, so or nullable. So I did not specify it for anything else because my data might be dirty, so I don't really want to require everything. I want to leave things empty if they're not there. But, well, idea I have to have it because I use it to merge and everything. So, and this is where I create the definition of my row. So I say, well, my row, I pick the data from my hash map or an object or whatever. This is where I get it from, and this is where I should put it in. So I put it into the ID thing here, which is the same thing down here, in here, right? And the same thing with all the other ones below. Okay, how many minutes do we have? Are we 0? Kevin is doing this. So I guess I'll leave you with this, but I could also show you things on Google Cloud and how things work. The problem, one thing I want to mention before I say thanks, is that you have to, like with all kind of conversion jobs, you have to make sure to know how your data looks like, and it might still fail. And I have this weird thing happening with, where is my, there it is. So the weird thing that happened is that in May of this year, they upgraded to a new version. And when they upgraded to a new version, they started doing like pretty printing the JSON that comes out. And I did not realize that until quite late afterwards. Because when I tried to run everything for 2018 data, everything worked perfectly. When I tried to run for everything for 2019 data, it went all the way halfway. It spent it spin up like almost 150 containers machines to process all that. It spent quite a bit of data, money as well. I mean, in comparison, because it was 3 kronas there, it was around 100 kronas here, so a bit more expensive, and failed. The reason was that Apache Beam by default, without doing anything, it does not support multi-line JSON objects. So then I had to create an ugly, ugly hack that I documented in a good, fantastic manner, another way you should not do, as a comment in my own Java file. So this is actually a hack to remove all the line shifts, the carriage returns, and so I can actually process 2019 data. So this is kind of the word of advice in a way. Be careful, and things might break, but that's because people design APIs in a bit weird way. I'll put some links and resources, and I have a blog post in progress about all this stuff, which I'll put on Twitter in near future. Right now I'm finishing up another blog post, and then so it's a second post in line, I think, right now. So it's coming soon. This is me on a social network called Twitter. This is me on a bit more traditional social network called email. It works. You can even do group chats. You can reply to all. Yeah. And well, this is my blog thing there. And well, I guess I'll say thank you very much for coming. And yeah, all the questions are